Solve the given initial value problem. So you're given this problem and the condition. So first of all, you need to find a minus lambda I, which is this one. So what is A? Let's call this matrix A, and then subtract it with lambda I. That gives you this matrix. Then you are going to find its determinant. That gives you this one. Distribute this out. Simplify it. After you simplify it, it gives you this one. Set this equal to 0 and then solve for lambda. You will get a complex answer, which is 5 plus and minus 2i. Okay, so let's find out what the eigenvector corresponding to this lambda. So let's take a look at the case when lambda equals 5 plus 2i. You can start with 5 minus 2i, but I like to work with a positive value first. So plug this into this matrix. That gives you this matrix and then augment it with 0. Okay, so now you can use either one of these equations to solve for the unknowns. So I'm going to use the first equation. So simplify this. It gives me 1 plus ui times k1 minus k2 equals 0. Solve for k2, I got 1 plus ui times k2. Then if I choose k2 1, my k1 is 1 plus ui, and my vector k is 1 plus ui 1. Okay, then my vector x is equal, because this is a complex eigenvalue. Once you find the first k, you can use it to write your solution, which is c1 times in the real number of vector k, which is 1 times cosine 2t. Where did I get the 2? The 2 comes from the imaginary part of lambda, okay, minus imaginary part of k, which is 0 times sine 2t, multiplied by e to the 5t. Where did I get the 5? This 5 comes from the real part of lambda, okay, and then plus c2. So for the second solution, it's just duplicate of this one, but there are a few difference, which is you have to have a plus and minus sign. So if you have this one negative, this one has to be positive. Okay, and then cosine side stay the same, e to the 5t, and you just switch these two vectors together. Okay, that gives you this vector x. Normally you would stop at this step, but because you are given an initial value problem, you have to find out what c1 and c2 are. So let's go further. Okay, so if I simplify this down, that gives me this matrix, this answer. So basically I multiply this in. So I multiply this into a matrix. Basically you multiply a matrix with a constant and then add or subtract them together. That gives you this matrix, similarly to this one. So multiply a constant with a matrix, then add them together. That gives you this matrix. Okay, then with the condition of vector x equals 0, plug in 0 for t. That gives me c1. Cosine of 0 is 1. Cosine of 0 is 0. Okay, so cosine of 0 is 1. E to the 0, which is 1. Okay, same thing here, plug in 0 for t, and then that gives you this one. And the condition said that vector x of 0 equals vector negative 2, 8. Okay, now the next step is to find c1 and c2. So as you can see, this it's similar like when you have x1 and x2, and here's you have two equations, the system of equations, and here is x1, here is x2, or x and y, and the right side is the equal parts. So if you take the vectors, put them into a matrix, that gives you this matrix. Okay, and then you reduce this down to a base matrix, which you have the line of 1 in diagonal. So which is similar, which looks like this. Okay, so if I reduce this down to a base matrix, I get c1 equals 8, C2 equals -5. So remember, the first column represents C1, the second column represents C2, okay? Keep in mind that, because I reduce this down to the upward diagonal line of 1, so I have to switch it. I have to take a careful look at which one is C1, which one is C2. You cannot assume that, okay, the top value is C1, the bottom value is C2. It's not true. Okay, now once you figure out C1, C2, just plug it back into this one. That gives you this answer, and it is your final answer eventually. That's it.
If you find the video is helpful, feel free to give it a like, share, and subscribe to my channel in order to receive the most current videos. Don't forget to hit the bell so that you won't miss anything. I'll see you next time.